Hey guys, welcome back to the channel. So in this video we would be solving this problem, which is find the minimum area to cover all ones, and this is the second variant of this problem. And we are also given a first variant of this problem where we are given a binary grid and we are expected to find the minimum area of the rectangle such that that rectangle covers all the ones which are present in the grid. So for the context of this video, let's see what is this second variant. So we are again given a binary grid and we have to find three non-overlapping rectangles and they should have non-zero areas. Okay, and these three rectangles should cover all the ones which are present in the grid, and we have to return the minimum possible sum of the area of all these three rectangles. And here the note is that the rectangles are allowed to touch each other but they should not intersect each other. Okay, so we are given this grid and here we are given that this is one rectangle, this is one rectangle, and this is the third rectangle. Okay, so the area would be 2 into 1 plus 1 plus 2 into 1, which is 2 plus 1 plus 2, which is 5. Okay, so now let's go to our whiteboard and see how we can solve this problem. So now let's consider this example and we are asked to find three rectangles. Okay, also in the first variant we were asked to find a rectangle such that it covers all these ones in the grid. So let's see first what is the thought process when we were trying to find the area of the rectangle which was covering all the ones, and this was the only one rectangle that we were asked to find. So in that case the intuition was we will find the first pointer which is having 1 from the upward direction. Okay, and again we check how much can we stretch this towards the bottom. So we were finding the last element in the bottom direction which was 1. So this or this, because we want the last row, and here we want the first row. Similarly in this direction we want the first column where 1 is present, and again we want the last column where 1 is present. So what we got is we got this area, like this part first if rows are concerned, this and basically this complete area, and this was omitted. Now our column said that we can omit this too, so we can omit this too. This area can also be omitted. Okay, so in the end we got the boundary as something like this, and here as our rightmost pointer is at this column, so we have to cover this also. So we got the boundary of this rectangles, and hence we can simply do the area as the number of columns into the number of rows. So we got our answer, right? So there was no problem when we were asked to find only one rectangle which covers all the ones. Okay, so let's extend this idea further to solve this problem. Now for this problem too, we will take this same example. Now here we want to divide this complete grid into three rectangles. Okay, so how can we divide this? The first division can be, let's say we consider this as a whole rectangle in a grid, and then we have two more rectangles, or maybe we have something like this, a whole rectangle, and then we have the small rectangles, or maybe we have two rectangles in the first part and a single rectangle in the second part. Or there is another condition which is, let's say here we have two small rectangles and one complete rectangle. Also please note that we can also get rid of this part and this part if here completely zeros are present, and same for all the other rectangles too. So basically the idea is to divide our complete grid into two parts first. So this is, let's say, part 1 and part 2, and then in any of the part we can divide this part into further separate rectangles, that is into two rectangles, and then we can split our grid in this fashion, and then we will take the minimum value of the area in this each of the splits, and we will just return simply this as our answer. So let's see how we can make this splits. So let's consider the same example. So what we can do is we can traverse the rows, and for each of this row we will divide it into upper half part and then in the lower half part, and then we can divide this further, like let's say we consider this upper half part and then we further divide it into two rectangles, or maybe here we will do only one rectangle but divide this into two rectangles. Then we will calculate our answer as this rectangle, let's say this is the first rectangle, plus let's say S1 and S2, that is we divided the second half rectangle into two separate parts. So yeah, in this way we can calculate the areas and do the summation. So here we iterate it over the rows and divide it horizontally, but another thing that we should consider is we should divide it in the vertical direction as well. So we will iterate over the columns, and for each of this column we will again divide it into first part and this second part, and then again as we did for the horizontal cuts, we will again take this part and this part, try to break it down further into two separate parts. Like every time if we are considering the first part as a whole part, then we have to divide the second part into two parts, and then vice versa, if we are considering the second part as a single part, then we have to divide the first part into two separate rectangles. So yeah, in this manner if we take the minimum over all the values, then we will get our final answer. So let's see how we can code this solution. So the heart of this solution is this part. So what it does is it calculates the single rectangle in a grid such that all the ones in that particular grid are covered. So here what we do is we pass our grid, then we pass the top, bottom, left and right pointers. So let's say if this is our grid, let's say this is some grid, and we are iterating over the rows first. So in this function we want to calculate the area such that this is the grid which is to be divided into only one part. So what we can do is we can pass the pointers as this is the top pointer, then this is the bottom pointer, and again this is the left pointer, and this is the R pointer, because we can consider this complete area, but we are only considering the first, like the first rectangle which is above this pointer. Okay, so in this manner we will pass all our T, B, L and R, which are the pointers. So we will consider 4 more pointers which will keep track of the boundaries of the rectangle which we are forming, such that in each of this boundary one is present. Like let's say if one is here and here we have zeros, so let's say here again we have zeros, so our top pointer will point at this, our bottom pointer will point at this, and then our left pointer will point at this because this part is 0. So the boundary on this extreme side is this, where 1 is present, and towards our right side this is the pointer. So we got this, this, this and this, and the area which is covered by this rectangle is this complete part. Okay, so this gives the area which is covered by one rectangle. So now we know that how can we create one rectangle such that it covers all the ones in the particular grid. Now let's get back to our main function. So here we are first iterating over the rows, and for each of these rows we will create this row pointer which is iterating towards the down direction, and let's say it is I. So what we do is we first split this in first part. Let's say this is one part and this is two other parts. So first we will go from 0 to I, and we say that this is our first part, and then we go from I plus 1 to this extreme end which is n minus 1, and we say that let's split this part into two further parts. Similarly we do the reverse of this, that is what we do is we consider this part and split it into two parts, which is split into 2 for 0 to I, which is 0 to I, and for this next part consider this as a single rectangle which is mentioned over here. And now as we iterated over the rows, we did the same thing for the columns. What we are doing is we are going from 0 to j, like we are iterating over the column, so j would be somewhere over here, and then we will take j plus 1 to this extreme end which is m minus 1. Okay, so we got this first part as 0 to j, and the second is j plus 1 to m minus 1. Okay, so here we divide it into one part and then two part, then again two parts at the start, that is for the first part, and then we calculate one rectangle for the second part. Okay, great. And then we do this for all the splits, and we take the minimum of that and we return this, as we are taking minimum in each of these iterations. So now we know that what is the underlying logic behind splitting into one part, but let's see how we can split it into two parts. So ideally, if we consider a particular grid, let's say this is a grid. I'll just make a quick grid. Okay, so here let's say I have this complete part and I want to divide it into two parts. So how can we do it? We can again iterate over the columns. Let's say I am iterating this pointer I, and if I am at a point, then this can be my one part and this can be my another part. Similarly, if I am iterating over the rows, so let's say j is there, which is iterating over the rows, so we can take this 0 to j as the first part and j to n-1 as the second part. So yeah, we did the same thing here. Is we maintain the grid dimensions. So here we are considering that n into m is the maximum value, which means that the grid is filled with ones completely. So now here in this part, as we are iterating over the rows, which is, let's say we are going from top to bottom, and here t is present, here b is present, and let's say I is somewhere over here. So we will take this one part and this another part, which is from I plus 1 to b. Okay, so here we have I plus 1 to b and we have t to I, okay, which is the first part. Similarly, what we will do is we will iterate over the columns. So let's say this is the iteration over the column. So j is iterating from this left to right direction. So we will have one part as L to j and the other one would be j plus 1 to r. So here again we have maintained this j as I, so it would be L to I and I plus 1 to r, which is this L to I and I plus 1 to r. Okay, and you can see that we are taking this complete rows, that is we are taking this complete rows because we are only splitting the columns. Similarly, here we took all the columns because we are splitting over only the rows. So yeah, so from this we know that a 2 is formed with 1 plus 1, and similarly the 3 is formed with 1 plus 2 or 2 plus 1. That is, the first part is having only one rectangle, the second part is having two rectangles, and this is the vice versa of it. So now here I have implemented the same solution. So now let's try to run this, and then let's try to submit this. So yeah, it gets accepted. Now I know that this is not the most optimal solution for this problem because it has cubic time complexity, and we do have solutions where we get quadratic time complexity for this particular problem. But the main motto of this video was to provide you a gist of how you can tackle grid based problems, such that you will divide the grid into smaller subgrids and then calculate the answer for that subgrid, then convert it into the answer which you require. So yeah, thanks for watching and subscribe to the channel for more such videos.